Welcome back, everyone. I can't promise to be as interesting or challenging as Les, but I'll do my best. Adapting to new normals, how to architect for ever-moving goalposts. Throughout this presentation, I think we should bear in mind a very important phrase in the discussion between Les and Andy just now. Context is everything. So, most people know me. If you don't, that's me looking important, and you can look it up a little bit later on. So, the agenda. First of all, the agenda in SABSA speak. A brief introduction to SABSA as a problem-solving framework. Even if you are already a SABSA practitioner, hopefully I'm going to present standard SABSA concepts in a slightly different way and combine them together in a new way. I'm going to look at the role of architecture in the modern enterprise. And we're going to build 4 brief SABSA concepts. They're called attributes, holistic risk, domains, and dependency modeling. We're going to use those to define control and enablement priorities, both today and for change. Deliberate change, a new project, a new initiative, or unintended change or undetected change, like a new normal. If you'd like me to do that in English, then we will. At any given moment, there is always too much to do and not enough resource to do it. And the next moment, absolutely everything changes beyond all recognition. So how can we tell what actions would have the greatest benefit at any given time in any given circumstance? How can a roadmap be defined when the landscape is changing constantly, dramatically, or both? Or what exactly is the role of strategic architecture for an organization focused on agility, adaptability, and technical innovation? The 5-minute rapid-fire introduction to SABSA, for those who don't know it, a structured, systematic approach to solve complex problems in strategy, planning, design, and operation. And it's a proven method for developing architectures at enterprise scale that can be calibrated to any scale of initiative or solution and that traceably demonstrates value to the business. That idea of calibration is, in my opinion, fundamentally important to any enterprise framework, because the reality is it will never get done on an enterprise basis unless you can apply it to a much smaller scale. The architect's eternal dilemma. You can't start from the end. Your organization will not sit still long enough for you to do everything at the same time. Now, this is not a sales pitch. I'm not breaking the rules of COSAC because SABSA is free use methodology. And COSAC is also the SABSA World Congress. It's used in all sorts of areas, although created from a security perspective. It's used for risk, it's used for strategic planning, it's used for enterprise architecture, resilience, trusted engineering, and so on. If you're really interested, afterwards, go have a look at the SABSA Institute. Okay. The complex system concept. The goalposts are always moving. Now, I, as a human being, I'm a complex system. Some would say I'm simple, but I am a complex system. Planet Earth is a complex system. The universe is a complex system. It's made up of many constituent parts which interact, are interdependent, and are conflicted with systemic relationships between them. It operates as an ecosystem, organically changing as each part innovates or changes its behavior. And each of those has its own objectives, its own success factors, its own methods, its own risks, and its own opportunities. But that enterprise also exists in an environment, and the environment itself is also continuously changing. So we can't define your complex enterprise by referring to its constituent parts alone, because no part is completely independent of the behaviors of all of the other parts. As if that's not hard enough, the modern enterprise doesn't just move the goalposts, it completely changes the game. I'm going to refer to a website of an insurance company in a few moments. Now, if you're of my particular age and background, you might perceive an image of an insurance company to be a bunch of old blokes in bowler hats carrying briefcases and umbrellas crossing the bridge to go into the City of London. But that insurance company now perceives itself to be young and innovative and creative and diverse, a totally different image than the one that existed just a few years ago. So business desires to change strategy and culture, top-down, and despite being an architect who loves top-down engineering, the reality is that technology innovates at the bottom, and business can sometimes benefit from that innovation. In this complex system, interdependencies and interactions present even greater risk. And one of the greatest risks of all is that we don't understand the risk in any new normal. We have to balance the cultural need for benefit and opportunity with our historical need to prevent things going wrong and control. And if we've learned anything at all in recent times, is that there will always be a new normal. So this is the reference I mentioned to the insurance company website. And look at the wording that's in that blue box. If I had not told you that was an insurance company, you may in fact never detect the fact that that's an insurance company, because it uses phrases and words like innovation, learning, visionary, revolutionize, not just once, but continuously. The future success of the organization depends upon its ability to understand complexity, be resilient to complex disruption, adapt to these ever-changing requirements. And that requires a completely new mental model in the way that we develop programs and solutions. The challenge, of course, is that complex systems are inherently difficult to model and describe. So the SABSA approach is to treat your enterprise as a single entity with complex properties, offer the approach capable of describing that complexity, and providing a means for translating it, creating common language, common principles, common means by which all of these diverse elements can collaborate, interact, and the risk relationships between them can be understood. Move into a slightly more real example. The business view at the top there for this particular F1 team, how do we win the World Championship? But the technician who's got to define the rubber compound is thinking, what rubber compound should I deploy? And we can't answer that question without context. Context is everything. There's simply not enough context for us to deploy the right control, the right solution, without developing more context. That decision about which rubber compound is required affects and is affected by many other unseen elements, like the power and the torque and the downforce and the weather. But fit the wrong tires and the business will fail completely to meet its objectives. The approach to this architecturally is to build layers of abstraction. I'm showing it the SABSA way here, but you will all have seen this in single sign-on, plug and play. It's always the same principle. To give each element perspective and context. Any element can be viewed in lots of different ways through filters, and we're providing the structure by which we manage complexity by top-down abstraction. There are different levels of nomenclature and specialist language and syntax, and each of the layers dictates the requirements for the one below it, and each layer serves the requirements of the one above it. The requirements define the need for controls, top-down, and the controls serve the requirements bottom-up. Now, in the SABSA universe, there are 6 layers. I'm not going to get into this in massive detail. Context is what we want to achieve, the thing that's important. Concept is the architect's approach, frameworks, and models. Logical layer is functionality and information. Physical layer is technology, infrastructure, and data. And the component layer is technical configuration and standards. And all of that has to be managed. But each layer defines the requirements for the one below. each layer has a context of what it's supposed to be achieving. And that creates a principle of traceability. Traceability for completeness, top down, that all of the requirements are being met and that the residual risk is acceptable to the stakeholders. And traceability for technology-led enterprises, that technical innovations at the bottom are justified by the value they deliver to the business. 100% of that value, Mary, not 30%. Otherwise, why are we doing it? So context is everything. In order to make the decision about which tires are required by the F1 team, we have to have a way of vertically correlating the technical solution with the business requirement. But we also need a way to consider the interactions with our peers, because the rubber compound can't achieve its contextual goals by acting in isolation. It has to be architected holistically with the engine, the body, the wings, and so on. Now, to bring you really up to date with modern thinking, the Hermagoras method. Hermagoras of Temnos, 1st century BC, was a fan of a technique known as inventio. And under inventio, a problem is not deemed to be properly considered unless you have looked at all 7 circumstances. And he gave those 7 circumstances names. They're perspectives by which we solve a problem. And they're called who, what, when, where, why, in what way, meaning process, and by what means, meaning capability. Now, there are many modern iterations of this. You'll see it in police investigation frameworks, journalism, Kipling's poem, and Zachman's architecture framework. And they've all merged in what way and by what means into the term how, but it's still the same thing. So for each of our levels of abstraction, we can now consider each viewpoint from the 6 perspectives, from its importance, from its risk, from its process, from its people, from its governance, jurisdiction, location, and from its time and dependencies. And this is going to allow us to work holistically by detecting and understanding and modeling the complex interactions between different perspectives, interconnectivity, interdependency, and systemic relationships. For example, the asset, the thing we care about most, does not exist in isolation from its risk context. It doesn't exist in isolation from the processes that use it, or from the people who use it or depend on it, or what jurisdiction it's in, and so on. And that set of 6 layers of abstraction, along with the 6 perspectives, creates a problem-solving matrix known as the SAS Matrix. This is the embodiment of the mental model that the SAS architects use to solve a problem. This is the same thing, but populated from the perspective of enterprise security architecture. And the key is that every element at every layer has context, both vertical and peer-to-peer. The relational structure of the elements is understood, and at any time, any element could change positively or negatively, affecting all of the other elements. Now, for the purposes of today's demonstration, I'm going to deal only with those 4 kind of terracotta-colored cells: attributes, risk, domains, and an architectural roadmap. Someone just put in the chat window, Nishant's just put in the chat window, architecture is architecture. Indeed it is. And we've just said, well, SAS is a structured systematic approach. The Royal Institute of British Architects says, no matter the culture, the sector, or the environment, architecture processes remain the same, but differ in the methods required to complete them successfully. So we have architectural interpretations for the business as a whole, or for risk, or for programs, or for initiatives, and they can all use the same architectural problem-solving structure. SAS's goal is to create a common structure, a common language, common principles, and a common means by which all of these diverse elements can collaborate and interact. And I'm going to try to demonstrate how that will work. At the enterprise level, that provides the context for program level initiatives. All of the projects and programs that we undertake are designed to meet the business requirements and deliver business value, 100% of them. Those programs and innovations drive the technology and solution innovations at the bottom layer. And the solution level innovations serve the program initiatives serve the business. We're also going to deal with it laterally, systemic relationships, just like tires and engines. The architectural structure provides those common points of reference between peers. So, next challenge. The world changes incredibly quickly, but the standards change very slowly. Forgive me for being my usual radical self, but if you innovate an entirely new solution, an entirely new technology, an entirely new approach, telling the CEO that this brand new thing that no one's ever seen before complies with a security standard from 2005 means nothing, because that was 2005 and everything changes. So the primary function of the enterprise architecture framework is to enable everything to work together holistically, whatever the elements are, whatever they become. And if it ever fails in that primary duty, it will fail in that primary duty if it is ever incompatible with methods or standards of the enterprise's elements. So SAPS is not a control standard because they all change. We're trying to provide the structure within which control decisions can be made holistically by balancing the risk. And if you look at principles, we could have mapped this forever. There is no conflict between what we're trying to do here and all of the pre-existing standards. In fact, we're trying to build a structure that allows you to use any combination of those standards that is appropriate to you. Last little piece of theory before we get to the point. The need for normalized, standardized language for requirements. Our stakeholders might understand the difference between an objective, a goal, a target, a driver, or a requirement, and they might not. There's a confusion that I experience frequently between what we want to achieve, how we will achieve it, and in what way we will achieve it. And requirements exist at various levels of abstraction and viewpoints throughout the whole organization. So we need some kind of standardized nomenclature to cross all of these cultural boundaries. We have a gulf in language and understanding. We talk the wrong language. We say to the head of the health service in the middle of a pandemic with 10-year waiting lists, what do you want to do about zero-day exploits? You're never getting on the agenda talking that language. Hey boss, what are your security requirements? And the answer is, I have no idea, that's why I hired you. Requirements are lost in translation. We offer technical solutions to business problems. Oh, a firewall will solve that. And we have an inability to agree on what really matters most. The head of process engineering cares about one thing, the head of technical programming cares about something else, a nurse on the ward cares about something else, someone working in national security cares about something else. And this idea that we protect assets is perhaps flawed. It's failing to understand that an objective is the greatest asset of all. If we look at asset registers around the world, we will find quite often that they omit the things that really matter, like national health or brand or reputation or safety or capabilities. So this normalized language is all about creating a way to understand what really matters. The SAPS attribute is what we call it. It's a normalized, measurable, in-context definition of what is important. Context is everything. They are keywords like reputation, health, safe, agile, simple, authenticated, trusted. Trusted means a completely different thing to Ministry of Defense than it means to a Chinese telecommunications manufacturer than it means to BT. Context is everything. But this language, being contextual, is also instinctive. If you imagine how much blood, sweat, and tears your bosses and stakeholders spent sitting in a room arguing about where the comma goes in their mission statement, they are emotionally attached to that language. So don't reinvent it. It's really quite easy. Here, for example, is the strategy on Shell Oil's website. We can see what matters most to them really quickly. Environmental, sustainable, market-leading, profitable, competitive, convenient. This is the Constitution of the UK National Health Service. And there's a lot of words on there, but what really matters, respect, comprehensive, equality, free, professional, effective, patient-focused, and so on. And we're going to use this normalized language to understand the relationships at different levels of the complex system. We're going to try to create systemic understanding. If risk is the effect of events on objectives, the effect could be positive or it could be negative. The things that matter most, what SABSA calls attributes, exist in a permanent state of risk tension and risk conflict. Increasing the success for one might in fact increase the risk for another. The simplest example, usability, cost, and security. There's a picture of a book there by Adam Kay, who writes comedy for TV these days. He was a doctor in the NHS for 6 years. And this is, in effect, his diary. His specialty was gynecology. So he's been on duty for 70-something hours. He hasn't had a break for 48 hours. He hasn't even had a cup of tea for 48 hours. He's the only doctor on duty. There's a queue of 5 or 6 ladies waiting on cesarean operations, and the emergency call will not stop ringing. One of the emergency calls is very serious indeed. He believes it to be an extremely rare condition that is of immediate threat to the life of mother and baby. But nobody's ever seen it before. He's never seen it before. There's no other doctors available. He tries to call the consultants, and the only one on duty has never seen it either. He has literally minutes to save the life of mother and baby. And in desperation, he thinks there must be a reference to this condition on the Institute of Gynecology website. Guess what happened? IT have blocked the Institute of Gynecology website because it's pornographic. Context is everything. And we have to understand the tensions between ability to do business and innovate and control. So that's what we're going to try to do. Here's a little pull point for you. The poll will pop up on your bottom of your window now. How many of us have been involved in an opportunity assessment versus how many of us have been involved in a risk assessment? How many of us have conducted both sides of the equation? Okay, second piece of SABSA conceptual modeling, it's called a domain. If an attribute defines the thing that is most important to us in common cultural language, then a domain defines its dominion of authority, its risk ownership, its governance, and its policy. And we're going to try to create certainty and clarity with this. And it's a holistic common structure and language. In the real world, we tend to do things like produce a 600-page long risk assessment on the network, and then tell Madam Business Person that she owns the risk, when in fact she has not the faintest idea what a network is or what it does. And so people back away from risk ownership because they don't understand it, it's not their thing. So we're going to try to reverse the entire universe to create a structure where ownership is embraced rather than resisted, where accountability and responsibility is crystal clear. The SABSA definition of a domain is a set of elements, area of knowledge or activity, subject to the common dominion of a single accountable authority. And if you're working in security, that's a set of elements, area of knowledge or activity subject to the common security dominion of a single accountable authority, which sounds really simple. But of course, somebody built the universe as a complex system. And these areas of dominion, or policy, if you like, exist in all sorts of different conflicting dimensions. We have a domain could be a process, it could be a system, it could be a jurisdiction, it could be a phone, it could be a group of people. And they all interact at lots of different levels. So our ability to architect risk and governance depends on an ability to define what really matters to each of those authorities. What is at risk, what must be governed, what is subject to policy. And now we're going to create the common structure of authority to overlay on the common structure of what's important. The rules: a domain has a single authority. Accountability means the buck stops here. It's not a committee, it's not a dotted line, it's never shared. The authority is accountable for the risk to and performance of the domain and must have a definable boundary. An accountable authority might delegate risk appetite or performance targets to lots of other people to do all the work and comply with the policy on his or her behalf, which creates the idea of a super domain. A set of elements, area of knowledge or activity, subject to the common policy of a single accountable authority that has delegated and authorized risk and performance dependencies to a lower authority. And the word dependency, used here for the first time, is going to turn out to be absolutely critical, because winning the F1 World Championship depends upon the tires, but the design of the tires also depends upon what's going on with the engine and the downforce and everything else that we do. So we're going to build a hierarchy, a model from these dependencies. And the simplest example is business availability. Business availability depends on information availability, which in turn depends on data. Systems availability depends on platforms and networks. Skills availability, facilities availability. And we put this dependency model into the SAPS domain model. There could be many ways to do this. This first example is typically for a very large, complex organization where accountability can be delegated. In other words, there's lots and lots of different managers and responsibilities here who can ultimately be accountable for each of the individual attributes. But perhaps you have a lean organization and you find that one particular authority, one domain, is accountable for lots of different pieces of the dependent model. Now, this is not an org chart. This is a dependency chart of risk and performance. It's not an org chart because that changes all the time. We frequently reorganize. Org charts represent chains of command, not what we want to achieve. A very quick illustration. On the left, we have an org chart. On the right, we have a SAPS domain model, fully delegated. And you will see entities who report to higher organizational positions are in fact authority and accountability peers from a risk perspective. So the first subdomain in turquoise color on the left is the CIO, and the next one is the CTO. But the CTO reports to the CIO organizationally, even when they are peers from the perspective of dependency. Similarly, CIO and COO are organizational peers, but the COO at the top of the domain model is dependent upon the CIO's ability to make information available. So let's go back to try and create a more meaningful example than pure theory out of the air. Here's the insurance company I mentioned again, and various extracts from their website. On the left, we have definitions of who they are. We have statements of corporate responsibility, right down to individual pieces of feedback on how good they are. Now, using only those extracts from the website, I created this model. I am not suggesting this is the real model for the insurance company. I'm just doing it for demonstration. We get the enterprise attributes from all of the keywords, what really matters most in this. Community-focused, adaptable, profitable, sustainable, global, trusted, innovative, visionary. And I've modeled the dependency on a fairly simple approach of people, process, and technology. Process dependencies, things like agile and efficient and productive. Technology, like reliable, architecturally open, migratable. And people split into two different subdomains: external people, the customers, and internal people, here called the entity. So internally, accountable, confident, diverse, empowered. Externally, accessible, accurate, culture sensitive, private, and so on. Now let's introduce micro level or program level architecture, the idea of an identity and access management initiative. And it has the attributes, the things that matter most to it, like authorized and access controlled and authenticated. And we can see that each of these has a relationship, which I'm going to spell out. There's a rule that I skipped over. Every attribute must be measurable. That's ultimately how we will demonstrate the value of a CISO to the business. Example here from the attributes taxonomy was smooth. We survey customers about their online experience of making insurance claims, and the customers immediately rate that experience from 1 to 5 stars, where 5 is best. The target is a satisfaction rating of 4.5 stars out of 5. Every performance target in the universe is a flip side risk appetite threshold. If my target is 4.5 stars, then I'm prepared to accept the loss of 0.5 stars. Anything beyond that is by definition unacceptable. So now we assess the performance of the security people's identity and access management system. And we find that this is a very complex multinational organization with hundreds of subsidiaries. And the users do not have unique IDs. The registry isn't unified, and not everybody's even registered the same way. So we can see that those 3 attributes are coded red. They're not performing within risk appetite. And now we can draw the dependency model to show the relationship between those attributes and the higher level ones. Because we don't have a unique ID and we're not unified, we have problems with accountability and accessibility and simplicity. Things aren't particularly agile or productive. It's not easily migrated. It's not easily protected. And we can continue that rational dependency chain even further to go up to the business attributes themselves. We can make a credible, measurable assertion that because we don't have unique identities, there is a risk to the adaptability of the business, the profitability of the business, and customer satisfaction. We need to understand that dependency for a number of different reasons. We have continuous planned change, and the architecture must cater for the timing and sequence dependencies of all of those projects and programs. There's always too many high priorities, so to become realized, the architectural strategy must determine a place to start. There will always be a new normal, so we have to cope with unplanned or unforeseen change. And the goalposts are always moving within each element of that complex enterprise. So that introduces the piece that I'm going to model through for you. It's SAP's time and dependency framework. We're going to create a time-based sequential roadmap for realizing the architecture. Define a starting point, what's most important right now in this context, and prioritize those actions to remediate risks or grasp opportunities. We're going to resolve the time and sequence dependencies within a complex enterprise, adapt to changing circumstances, and even deal with resilience. Now, this piece of work was originally introduced to the SAPSA community by Andy Clark, whom you've just seen on screen, and it is in turn based on a piece of work by John Gordon, who was at Southampton University, I think. John Gordon was a critical national infrastructure risk guru, and this is called dependency modeling. Now, Andy initially introduced this at COSAC APAC in 2019, and indeed there's a presentation on Connect One, which you can view on demand. I'm taking that original presentation, an original piece of work, and putting it very firmly in the SABSA context here. The principle is that we cannot control all dependencies in the complex model, and we can't predict all failures. Risk increases with the lack of understanding of those dependencies, and better understanding of the dependencies increases resilience to failure. So we start with our attributes, the things that really matter in their dependency taxonomy. And we give them 2 states. You could use more than 2 with warning states, but we need at least 2. That is, the attribute succeeds or fails. We meet our target or we don't. We are within risk appetite or we're not. And we build this with a probability analysis and with and or relationships. Simple, cheeky example. Our risk assessment tells us that the probabilities of being happy are calculated on that chart. And according to Dave Gorman's great astrological experiment, the contributing metrics to happy, the dependencies on being happy, are love, health, and wealth. Now, I should point out, I've used very poor terminology just then. It is not the probability of being happy, it's the probability of meeting my requirements to be happy. Will I be as happy as I said I wanted to be? And because this is an and relationship, it creates weakness rather than resilience, because I need all 3 of those in order to be happy. But now we zoom in with the subject matter experts, we go down the layers of abstraction, and we find the wealth experts telling us that there are 3 dependencies here. I could continue to be salaried, shown at 0.85 probability. I could be supported by my family, shown at 0.5 probability, or I could mysteriously find a rich uncle I'd never met before in my life, shown at 0.05 probability. That's an or relationship. Any one of those will in fact allow me to meet my targets for wealth. And you can see that the effect of that through the dependency chain is that my probability of being as happy as I want to has now changed to 418. And the simple lesson in that is that and conditions and dependencies increase risk and decrease resilience, or dependencies decrease risk and increase resilience. So when we look at the attributes profile in SABSA and create the understanding of which technologies, controls, and solutions deliver those attributes to the business, or relationships are going to be very valuable because they decrease risk and increase resilience. To bring that into topical scenario, business availability on the left is our ultimate business goal, and we have the dependency map a little more complex than I previously showed it, but those attributes go down through the layers. On the right-hand side, data center 1, accessible, data center 1, functional, and so on. That probability, once again, it's not a risk probability per se, it's the probability that we will be as accessible as we need to be. And that 99 is not, on the right-hand side, is not 99% available, it's 99% probable that we will be as accessible as we need to be, that we meet our objectives. And when we run the mathematics of this dependency chain, we can see that we're about 71% likely to meet our intended goals and objectives given that state of play. But what happens if those end dependencies were to fail? Well, we can model that. Instead of probability here being 99, 90, 99, 90, we set it to 0, one at a time. And we can see the failure mode analysis. There are 4 critical dependencies: the application functionality, data accessibility, staff competence, and staff health. Any one of those failing will in fact fail the entire business objective. We will not meet our availability targets. But we can also balance the risk. Let's look at opportunities. What if we set that end point to 1? What if we could make it better? What if we could guarantee that it meets its targets? Well, now we see a slightly different pattern. We can see that the health of our staff is clearly the most important value contributor, closely followed by competence and data accessibility. Of course, balanced risk means looking at it both ways, so we can now combine failure mode analysis with success mode analysis, and we can see that health of the staff is in fact the single greatest dependency to our success, and that investment in the health of our staff is the single biggest way to guarantee value. But then, of course, we get a pandemic. And we can see that the accessibility of the data centers is now decreased because of restrictions and lockdown. The health of our staff is now decreased because of infection. And we can't get anywhere near the retail stores, this is a retail company, obviously, because of lockdown. So it's set to fail state. And you can see that the effect of that is that the probability of being as available as we need to be has reduced from 71 to 36. If we run that through the dependency model, fail state and success state, we can see that now there are 6 dependent failures: functionality of the app, accessibility of the data, staff competence, staff health, host availability, and network availability. Well, that's a lot of failures, and that's an awful lot to do. What was I saying about too much to do and not enough resources to do it? Where is the number 1 priority? Let's add the value perspective. Let's set the end attributes to 1 and see the effect. And while it was important to protect against failure of a number of end dependencies, the greatest enablement, the greatest value clearly comes from the health of the people, followed by data center accessibility. The health of the people, which was previously only marginally the most sensitive end dependency, now becomes a clear and urgent priority. As a security and risk professional, I want to deal with this scenario. And dealing with the risk, positive or negative, means choice. I can manage the event, or I can manage the state in order to affect the probability of the event. I could deter the threat or encourage the opportunity. I could decrease weakness, or I could increase strength. We could also manage consequences. So be resilient to negative impact, leverage positive opportunity, and replace those and dependencies with or dependencies. So if I populate that health service scenario, a way to manage the event for the attribute staff health is vaccination. A way to manage the state of strength or weakness is isolation. And since there's only one of me, I couldn't think of a way to create an OR relationship other than cloning myself. For data center accessibility, we could treat the event by decreasing travel restrictions. We can manage the strength or weakness by enabling home working. And we can manage the consequences by creating an OR relationship, that our data center is accessible physically or logically. And if I run those attributes through the same dependency calculation and measure the effect one at a time, if we vaccinate only, then the probability of being available to the extent we need increases to 6 to 1. If we isolate only, it increases to 491. If I remove travel restrictions only, it goes to 46. And if I provide logical access via home working, it goes to 452. Problem. As the sports people will tell you over and over again, concentrate on controlling what you can control. Parts of this scenario are beyond our control. A domain being accountable for the performance of his or her own dominion has control. They can affect their own level of strength or weakness. But now we have an external domain where events affecting our attribute performance and risk are beyond our dominion of authority and controllability. There's a trust relationship. We could try to solve the problem in that area. We could try to deter the events that would adversely impact us. We could try to encourage events that positively benefit us. In this scenario, we could fund vaccination research in the hope that we get an easier, faster, cheaper vaccine for the whole planet. We could lobby politically to try to remove travel restrictions. But those are ultimately uncontrollables. They are beyond our dominion of authority. So let's start by controlling what we can control. And now our strategy comes down to isolating our workforce and providing logical access via home working. The physical access on the right-hand side is still failed, but now logical access is introduced to succeed. And we dramatically affect the probability of meeting our availability targets, because now it's 8-2-1. The world has changed, so now we model the next step. Let's once repeat the function of fail state and success state analysis. And we can see that the new priority, tomorrow's #1 step, is in fact staff competence, because that has the greatest overall balance of value and protection. And now we have an entirely new strategy. The business changes its landscape completely. It moves the goalposts beyond recognition. It says, we've discovered during this lockdown thing that retail stores aren't really very effective, so we're going to concentrate on online stores and close all the physical stores. So the enterprise may redefine what is the success state. It may redefine its risk appetite on attributes or performance requirement on attributes. And it might in fact introduce entirely new ones. So now what do we do as architects to understand that changing landscape? We take the attributes model and we set the top level business attributes to fail. We reverse the probability calculation, and that will identify the most likely causes of that failure, which in this case are attributes 2A and 3A. That's where the investment should go, that's where the control focus should be. We can also set the business target to succeed, set it to 1 and reverse the probability calculation. And now we can see that the attributes most likely to deliver value are 1B and 2D. And that's where we invest our efforts as security professionals. We now create the roadmap for a new vision, a gap analysis between the current state and the target state. And we can see that that informs us that the roadmap to meet new enterprise macro level requirements involves a combination of stuff we've already got with its existing dependencies and new stuff that we need to do. And that new stuff is clearly defined. We can look at the same technique, but this time at a non-enterprise level. So this previous slide, the new enterprise attribute on the left, the gray one, it's an entirely new business initiative that's driving projects and designs and solutions underneath. But this time we introduce a new solution or a new project or a new initiative at level 2 of the attributes dependency model. And it leverages the existing knowledge base from the dependency tree, and it introduces new attributes with new dependencies. Bi-directional dependency analysis between target state and current state. So that's the demonstration finished. I'm only about 4.5 minutes over. We covered a very, very brief introduction to SABSA. We looked at the role of architecture in a modern complex enterprise. We briefly introduced the 4 SABSA concepts and used them to define prioritized actions that systemically understand the cause and effect of the controls that security deploys and the value that security delivers. In the process of that presentation, I introduced a little poll. I have been involved in a risk assessment, 98.2%. I've been involved in an opportunity assessment, 42.9%. Even though our own standards like ISO 31000 say that the whole point is to minimize damage and maximize benefit, the whole point is balance, we as security professionals generally completely ignore the opportunity modeling about how to do things better or faster, all of those innovations and agility and adaptability that the business really needs. Think about how your stakeholders get a bonus or what happens in their annual appraisal. It is very rarely based on the fact that they slowed anything down, that they deployed controls, and that they stopped to check. Almost exclusively in the commercial world, slightly different balance in public sector, almost exclusively the benefits and rewards of our stakeholders come from innovation, being agile, being adaptable, creating new things, not stopping new things. And that's ultimately how we deliver value. If our approach to risk and security is based only on the negative side of that equation, we completely lose the context that exists for real people like Dr. Adam Kay. We deploy controls in complete isolation from the context that exists to drive value and benefit. And that can be very, very dangerous in a complex system. First question is from Helvi. It's a no-stage question again, so I'll read it out myself. Many security professionals, including CISOs, are overloaded with work originating from compliance and control frameworks, and often obliged to do compliance-driven, not business-driven security. As in a heavily regulated business, compliance is a must to be able to do the business. How could we change this situation, which is not an organization's internal issue, but a more general problem? Would changing the way to write standards help at all? Oh, Helvi. I love regulations that are written by people who've never had to do it. Let's deal with it one part at a time. If I'm in an organization which is compliance-driven, you have obliged to be compliance-driven in your question, I'll start by asking why. Is it because I simply cannot operate if I don't have a license or a certificate? Or is it because the stakeholders have never had security communicated as a value and a benefit? That is, everybody else says, deploy NIST, deploy 27,000, and therefore that's what we must do. And that is security with no context at all. That is the thought process that ends up with a doctor needing to perform an emergency operation and being completely unable to access the information that's required. So what I would do is to build that dependency structure. And it's not actually that difficult to define the business's attributes and say what happens to the things that really matter if we are compliant, and what happens to the things that really matter if we are not compliant. And try to educate the stakeholders that there's more to life than being compliant with a standard. The second part of your question, Elvi, was should we change the way standards are written? The way standards are written is already an incredibly cumbersome process. And given that I said my point about innovating, if we innovate a new world, then it's incumbent upon us to innovate the new standards, not follow old ones. then I would say yes, I think it's really, really important that the way we write standards changes. But that's very easy to say and very difficult to do. Andy, or I think Andy just popped up a survey. Can we have a poll on how many attendees have been involved in dependency modeling? Yes, 16.7%, no, 83%. I'm pleasantly surprised at 4 yes votes in there. Interesting. I should really let you comment on that, Professor Clark. Okay. If that's the only questions there are, then I've managed to survive 5 minutes early by talking really quickly, which reclaims a little bit of time. We officially built in a 15-minute break at this point. I'm happy to continue with the 15-minute break and see you all back on camera then. And next up will be Helby herself, so perhaps she can try to answer that question for me. Thanks very much. See you in 15 minutes.